Now let's turn to search. Search is really just a walk that stops early. We walk the list looking for a value, and we stop the moment we find it. Search is just a traversal that stops early. We walk from head, and at each node we ask, does this node's data equal the key? Let's trace searching for 30 in the list 10, 20, 30. Each row is one hop, and the rows stay. Hop 1 cur is at 3000 node 10. 10 equals 30. No, so we move on. Hop 2 cur is at 7000 node 20. 20 equals 30. Still no. Hop 3 cur is at 4000 node 30. 30 equals 30. Yes, that is the hit. We return the address of this node 4000. And the absent case. Say we searched for 99. Every row would say no. The walk falls off the end, cur becomes null, and we return null. So null is the clean not found signal for a pointer search. Here is that same search in C. The for loop walks cur from head while cur is not null. If cur arrow data equals the key, we return cur, the node's address. If we fall off the end, we return null. Now the cost of that search. Best case, the match is right at the head, big O of 1. Worst case, and on average, big O of n, a full walk when the key is last or missing. A list has no order to exploit, so unlike a sorted array it cannot binary search. One key idea. Because this search returns a pointer, not found is null. But an index returning search, like binary search in chapter 2, returns -1 instead, a documented sentinel that is not null. Match the not found signal to the return type.